You are welcome to my YouTube channel. Today we are going to be looking at how to solve simultaneous equations using Cramer's rule. The first thing I want you to know is that in this tutorial, you are going to learn how to find the determinant of a 3x3 matrix. At the same time, you will also learn how to solve simultaneous equations with 3 variables using Cramer's rule. Let's go. The first thing we have to do, let's extract the coefficient of the variables in each of the equations. We have 3 equations. In equation 1, equation 2, equation 3, like that. So in equation 1, the coefficient of x is 1, y is 1, and the coefficient of z is also 1. While in equation 2, I have 1, minus 1, 1. Equation 3, I have 2, 3, and 1. So I've extracted the coefficient of the variable. So the next thing I'm going to do now, I'm going to find the determinant of this matrix. Now to find the determinant of a 3x3 matrix, we are going to use one of the row or one of the columns, one of the rows or one of the columns to multiply while we reduce it to a 2x2 matrix at the same time. So let's say here is plus, minus, plus. So we want to use the first row to multiply. So I'm going to have plus 1 into, when you take plus 1, when you take this, it will actually cancel the row and the column of that particular element that you have picked. So this will cancel and this will cancel. So I'm left with minus 1, 1, 3, 1. Then minus, I'm picking this element now, minus 1. Into, so this row, the row will cancel and the column of that particular element will also cancel. So I'm left with 1, 1, 2, 1. Then plus 1, this row, this column, and this row will cancel. So I'm left with 1 minus 1, 2, 3. So that is that. So the next thing is to find the determinant of each of them. I have my delta is equal to 1 into bracket. I will multiply the first diagonal minus the second, the product of the second diagonal. So I have minus 1 minus 3. Then I have minus 1 into bracket this diagonal, the product of that diagonal minus the product of this diagonal. So I'm going to have 1 minus 2. The same thing, the product of this diagonal minus the product of this diagonal. That is going to be plus 1 into bracket 3 minus 2. Therefore, I have 1 into bracket minus 1 minus 3 is minus 4. Then minus 1 into bracket 1 minus 2 is minus 1. Then plus 3 minus minus 2, that is 1 into bracket 5. So at the end of the day, I will have this minus 4 plus 1 plus 5. Therefore, the determinant of this matrix is going to give me. So I've gotten the determinant of that matrix. The next thing I'm going to do, I will evaluate delta x. Delta x will be gotten by replacing the x coefficient, the column of x, with the constant term, 6, 2, 11. I will find the determinant of this matrix just the same way I did the other one. Once I pick an element, I will cancel the row and the column. So I'm picking 6. I want to use the first row to multiply. I will pick 6. That does not mean I cannot use any other row or any other column to multiply. But you have to know some things before you do that. You must know how to attach your sign because all the signs are alternating. If here is plus, minus, plus, here will be minus, plus, minus, and so on. But that's not what we are talking about today. Okay, let's continue. I have 6 into, so I'm left with minus 1, 1, 3, 1. Then minus 1 into this column will cancel and the row will cancel. 2, 1, 11, 1. Then plus 1 into the column and the row will cancel. 2 minus 1, 11, 3. So let's solve this and get the final answer from this. So I have 6 into bracket. Don't forget you multiply the first diagonal minus the second diagonal. So I have a minus 1 minus 1 minus 3. Then minus 1 into bracket the product of this diagonal minus the product of this diagonal. That is 2 minus 11. Then plus 1 into bracket product of this minus the product of this. 6 minus 11. Therefore, I have 6 into bracket minus 1 minus 3 minus 4 minus 1 into bracket 2 minus 11. That is minus 9. Plus 1 into bracket 6 minus 11. So I have 6 plus 11, that is 17. Which is equal to 6 times minus 4, that is minus 24. Plus 9 plus 17. 2. I will repeat the same process for delta y. Delta y will be equal to, I will use the constant term to replace all the column of y. So I have 1, 6, 1, 1, 2, 1, 2, 11, 1. Let's do the same thing. I will use this element to multiply, then the rule and the column will be cancelled. So I have 1 into 2, 1, 11, 1. Then minus 6 into 1, 1, 2, 1. Then plus 1 into row and column cancel. I have what? 1, 2, 2, 11. So we have 1 into bracket. Multiply the first diagonal for this minus the second diagonal. So I have 2 minus 11 minus 6 into bracket. The first diagonal minus the second diagonal, that is 1 minus 2. Then I have plus 1 into bracket 11 minus 4. So I have 2 minus 11, that is minus 9 times 2. I have minus 9. Then minus 6 into bracket 1 minus 2 is actually minus 1. Minus 1 times minus 6, I have plus 6. Then plus 11 minus 4, that is 7. 11 minus 4 is 7. So let's add the whole of this together. At the end of the day, I have 4. Now remaining one more to go. That is for delta z. How do we get delta z? I'm going to use the constant term to replace all the elements in the z column. So I have this 1, 1, 6, 1 minus 1, 2, and I have 2, 3, 11. So we are going to find the determinant of this. First, we have plus, minus, plus. Now we are going to use 1 to multiply. So I have 1 into, we cancel the rule and the column. So I'm left with minus 1, 2, 3, and 11. Then the next thing is minus 1 into the column and the row will be cancelled. 1, 2, 2, 11. And then plus 6 into the column and the row will be cancelled. I'm left with 1, minus 1, 2, 3. So let's now multiply. This is 1 into bracket, product of the first and the product of the first diagonal minus the product of the second diagonal, minus 11, minus 6. And I have minus 1 into bracket, this minus this. That's 11 minus 4. Then I have plus 6 into bracket, this minus this. That is 3 minus 2. So at the end of the day, minus 11 minus 6, that is minus 17 times 1, minus 17. Then 11 minus 4, that is 7 times minus 1, minus 7. 3 minus minus 2 is actually 5. 5 times 6, that is going to give me plus 30. So let's add the whole of this together so that our delta z will be equal to, we've gotten the value of delta x, delta y, and delta z. Let's write it out. Delta x is equal to 2. Delta y is equal to 4. and delta z is equal to 6. So delta y is equal to 4. Now to find the value of x is equal to delta x divided by delta. Don't forget we got our delta to be 2 also. Let's go back and check for the value of delta. The value of delta is equal to 2, and the value of delta x is also equal to 2. So x will be equal to 2 divided by 2. Therefore, x is equal to 1. Y will be equal to delta y divided by delta. Delta y is equal to 4 divided by 2. Y is equal to 2. And then z is equal to delta z over delta, which is equal to 6 divided by, what is delta? 2. Therefore, I have z is equal to 3. The values are x is equal to 1, y is equal to what? 2, and z is equal to 3. We are going to check using one of the equations. Let's use equation 1. X plus y plus z is equal to 6. That is 6. So the equation is balanced. The equation is correct, it's well solved. Thank you for watching, and I really appreciate if you would kindly help me to subscribe to this YouTube channel so that I will be motivated to do more. Thanks. God bless.